heads a little bit. You see the blender will go on top of the table there. Even found some time to practice some Spanish and a little bit of Quechua with the locals. So, after learning the tricks of the trade, I went about overhauling the design. The main design improvement goals that we had were to improve the usability of the machine. Some of the bits were a little bit fiddly to do and you had to know exactly how to move them. And we also wanted to simplify the manufacturing of the device. So I built a second prototype. Didn't look very pretty, but it did prove that it could be made with the tools that they had in Marco's workshop, which, as you can imagine, are significantly more limited than the tools we had in the workshop at Sheffield University. So this is Carlos riding the bike here. Carlos liked the design, but he knew he could make something a lot better and a lot quicker, so we built a third prototype together. With a bit of cutting, a bit of chopping, a bit of measuring, a bit of welding, we came up with this. We tried it on the bike and it didn't fit. The frame was the wrong size. We hadn't measured things properly. Carlos had done it all by eye, and I assumed because he's made hundreds of bicycle machines before that he knew what he was doing, but more for me. So we did a bit of chopping and re-welding, and then we came up with this. This is where we're having technical difficulties before, so sorry, but I'm just going to have to go to another window. Hopefully we will still have open the video, which I've got to include in my email to Katie. The best quality that I'm doing. So this is a video that I made and put onto YouTube, and it's really the reason why I'm here at the conference today, because I sent it to Katie and she saw it and thought it was a great project. So just a little bit about the bicycle pump. Here's Carlos pedaling on a bicycle. You can see one of the main improvements we made to the design was getting rid of the A-frame you saw on the first diagram and replacing it with angle iron, which is cheaper, easier to work with, and also replacing the height adjustment ply as bicycle seat post and a seat tube so they can move up and down within each other. A lot simpler and uses parts that are already designed to do this. So this is Jamie, probably the cutest of our neighbours. It's probably about 30 to 40 litres per minute going through the machine at the moment. Another big improvement we made to the design was replacing the cylindrical part that we put in the middle of the machine with a suggestion that Carlos came up with. Simply use the original casing and cut a slot in it. Far easier than a part that I had decided to get the workshop to make in the University of Sheffield, but unfortunately it had taken them 8 days to make it on a CNC machine. Not quite so practical when you only have hand tools and a few basic machines in Guatemala. So Carlos is now going to demonstrate for us the main feature of the design, and that's its mobility. When you're done pumping, flip it upside down, fasten it on, and then you can pedal away, take the machine to where you want to go next if you want to do some more pumping, or you can put it away safely inside at the end of the day. This is another feature we added in Guatemala, the slot that you can see, and you will be able to see when we get to the right angle, cut into the front of the frame. So you put a nut and bolt through this slot, and it also goes through a hole where the original rear reflector of the bicycle would have been. We've taken that off and allowed you to fasten the two together. We used a piece of string to do this in the UK, which didn't look quite as professional. This machine was actually sold for 1,200 quetzales just after I left, so that's about £100. Since I left, Carlos has informed me that they've now sold 6 more of these machines, and they're going to continue building the design. It's a lot different to a lot of the other machines, which are static machines. This one gives you mobility, so there's scope to improve this design or to adapt this design to the other machines, make them mobile as well. So plans for the future. I made a construction manual of how to build one of these pumps. Quite unfortunately it's all in Spanish at the moment, so I want to translate that. It's fully available on MyPedal's website at the moment. Unfortunately, it's not much use unless you speak Spanish. So another idea for continuing the project is building a bicycle-powered generator which is a possible project for engineers without borders Sheffield in 2011. I want to use the same kind of design, like the frame that flips upside down. Simply replace the pump by an electric motor operated in reverse or a car alternator, and you can use it to charge a car battery, which you can then put on top of the frame and transport around. And then I've been speaking to a number of other students as well about placements in my pedal this summer. Other people want to go do the same kind of thing, build up bicycle machines, and I'd like for someone else to be able to do a similar kind of thing to what I did. Do a research project designing one of these machines, maybe for their master's, bachelor's thesis, and then go to my pedal the next summer and put it into practice, see whether it really works. Maybe one day there'll be an EWB placement going to my pedal and Guatemala. Okay, thanks very much for listening everybody, and that's the end of the day, so thanks for your attention, and any questions?